Hello and welcome to another session in physics. In this session, we'll be looking at the topic, the distance displacement time graphs and the speed and velocity time graphs respectively. But before that, let us review the previous lesson. Welcome back. At this point, let's look at the definition of graphs. When we talk about graphs, we are simply referring to the representation of quantities using lines and shapes respectively. We have different kinds of graphs. We have linear graphs, we have straight line graphs, we have quadratic graphs, and so on and so forth. Now, when it comes to the motion of an object, in physics, the motion of an object is best represented or described using graphs. When it comes to the motion of objects, we have three main graphs in question. The first distance time graph, the second one is the displacement time graph, and the third one is the velocity time graph. Now let's analyze them one after the other. When we talk about distance time graph, we are talking about a graph of distance time. And in this kind of graph, it is the gradient or the slope of that graph that gives us the average speed of that body. Under the displacement time graph, it is also the gradient or slope that gives us the velocity of that body. So that's more like displacement time. And then for the velocity time graph, the velocity time graph is more useful in its application more than the above mentioned graphs. The reason for this is because the velocity time graph provides us with more useful information concerning the motion of objects. From graphs, velocity time graphs, distance time graphs, displacement time graphs, we can obtain the following information: acceleration, retardation, distance, average speed, respectively. And we're going to see how by taking one very nice example in this particular topic. Also, in a velocity time graph, the motion of objects can form shapes. You can have something time graph and shapes are formed. You have something like this is a trapezium. You can have something like the motion that will just look like this. This is a triangle. You can also have something like this, and so on and so forth. Right angled triangles, they can form shapes such as squares, triangles, trapeziums, rectangles, or a combination of two or more of those shapes. For example, they will tell you this is a velocity time graph of velocity against time. Okay, they'll tell you that the body started from rest, and that from rest this body started accelerating from rest, and then it moved with constant velocity, and then probably accelerated again, and then it decelerated to rest. So these are some shapes that can be formed, and we'll have a combination of a triangle together in one particular question. Thus, the sum of the shapes of the areas, the sum of the areas of the shapes formed corresponds to the distance that has been. So this is a trapezium. The area of this trapezium now gives us the distance that has been moved. If this is a trapezium and this is a triangle, the sum of the area of this trapezium and the area of this triangle gives us the distance that has been moved by this object, or that has been covered or traveled by this object. Now let's look at this very interesting example. It says that a car starts from rest and that this car accelerates uniformly until it reaches a velocity of 30 meters per second after 5 seconds. And then it begins to travel with a uniform velocity for 15 seconds, and then finally it is brought to rest in 10 seconds with uniform retardation. And the question says we should determine the acceleration of the car, we should determine the retardation of the car, and determine the distance that has been covered after 5 seconds, and the total distance that was covered by the body using either the graphical or analytical method. So let's start out by drawing the graph. Let's say the car starts from rest. So before that, let's just identify our x and our y-axis. Remember, it's a velocity time graph, so it's a graph of velocity against time. Of course, velocity is the y-axis, time is the x-axis. So it says this body starts from rest and accelerates uniformly. That is acceleration. Acceleration slowly until it reaches a velocity of 30 meters per second. So I'm just going to get this a little bit higher, and at this point it's going to give us 30 seconds, whereas this is our point of origin, which is 0. And then this body travels with a uniform velocity. It means the speed got steady, and after traveling with a uniform velocity for about 5 seconds, then it 15 seconds rather, and then it was brought to rest in seconds. So this is more like the body coming to rest after 10 seconds. So I'm just going to try to divide it into segments here. From this segment here, you see we have about 3 shapes. We have here a triangle, we have here a square, and then we have here a triangle as well. But this total shape form is called a trapezium. So the area of this trapezium is going to give us the total distance covered by this body. Now, what was the time that it took this body to reach an acceleration and to reach a velocity of 30 meters per second? It was 5 seconds. So from here to here was 5 seconds. Then from here to here, the time spent for the uniform velocity was 15 seconds. So when you add 5 to 15, you are going to have about 20 seconds. And then it took 10 seconds for the body to come to rest with uniform retardation. So add 10 to 20, we're going to have 30 seconds as well. So I'm just going to try to label this diagram now. So this is O, I'll call this A, and I'll call this B, I'll call this C, D, and E. This is really important because we're going to use the idea of geometry to get some certain calculations that are done. So this is our velocity time graph here, because so we need to find the acceleration of the car. For us to find the acceleration of the car, we said acceleration of the velocity time graph is found by calculating the slope of the area in question, and this area is the area in question. So the acceleration, which is A, is going to become the slope of OA, that is here, OA, slope of OA, which is going to give us change. Of course, we know slope, change in y over change in x, and change in y in this instance is AE divided by change in x, which is EO. So our AE is going to become 30 minus 0, our EO is going to become 5 minus 0. In other words, final y, which is 30, minus initial y, which is 0, final x, which is 5, minus initial x is 0. Initial x being that the body started from rest. So when you subtract both together, you're going to have 30 divided by 5. And 30 divided by 5, you and I both know that it's going to give us 60 meters per square. That is the acceleration of the body. And now at this point, let's also look at the retardation, which is the second thing that the axis tries to find. The retardation. This is the B part of the question. This is A part of the question. The retardation of the body. The retardation of the body is going to be by calculating the slope of BC. The slope of BC is CB over CD. That is CB over CD, change in y over change in x, and it's going to give us 0 minus 30 all over 30 minus 20. So we're going to have minus 10 over 10. Therefore, negative acceleration, which is retardation, is going to become minus 3 meters per second squared. It is minus because it is retardation. At this point, let's continue the solution by C, which is the distance that was traveled by the body. So distance traveled after 5 seconds, that's what they asked us to find. Distance traveled after 5 seconds. And for us to find the distance traveled after 5 seconds, we're going to get it by finding the area in question. And that area in question of AEO. And you know that area of AEO forms a triangle, a right angled triangle. And the area of a right angled triangle is given half base times height. Half base times height. which means half times our base. Our base is 5 and our height is 30, which is going to give us, when you do your calculations, well, you're going to have 75 meters. And now the final part of the question, which is the total distance that has been covered. Total distance covered by the body. It is going to be equal to the area of the trapezium. Now, by the area of this trapezium, we are talking about the angle OABC. So we're trying to use the graphical method to find the answer to this question. The area of the trapezium is given by half brackets base, which is AB, plus height, length rather, which is OC, and then you by the height, which is AE. It's going to give us 15 plus 30, close bracket, 30 as well, which is the equivalent of the height. So when you run your calculations very well, everything here is going to give you about 675 meters. That is the total distance that has been covered by this body. And now, find the total distance covered by the body. We can decide to determine the various stages of the journey, which was 3. First of all, the body accelerated, and after accelerating, the body moved with constant velocity, and after moving with constant velocity, the body decelerated back to. So you can decide to do it individually, and doing it individually, you get the various distance were covered by that body. And when you add all of them together, the distance covered for acceleration, distance covered for constant velocity, plus distance covered by everything as well will give you 675 meters. Thank you for joining us in this lesson, and to refresh your memory from what we just discussed, please take the test that will appear on your screen.